Founded in September 1993, the Amana Group has grown to become a regional group of companies that excels in servicing the industry and commercial construction industry throughout the Middle East. The Amana Group today stands proud with over 11,000 employees across over 7 countries. With every new day, Amana caters to clients across the region in sectors of agriculture, aviation, automotive, food processing, institutional, logistics, manufacturing, oil and gas, power and water, and retail. This is achieved predominantly through the operations of its subsidiaries, Amana Contracting and Steel Buildings, Amana Pipeline Construction, and Amana Industries. The synergy provided by these subsidiaries allows Amana to offer complete turnkey solutions to their clients. The footage you're about to see focuses on the Amana Contracting and Steel Buildings' ability to achieve its targets of excelling beyond a client's expectations by completing projects on time, under budget, and within the quality requirements. For this project, we will give you a walkthrough of a 29,000 square meter steel rebar rolling mill located in the United Arab Emirates. At full capacity, this factory will have the capability to produce 1 million tons of steel per year. Amana's scope of work on the project includes the preparation of architectural drawings, structural design calculations, in addition to the construction of the facility. The factory is made of pre-engineered steel structures with all related works including reinforced cement concrete substructures. The construction of the factory also includes reinforced cement concrete ground floor slabs and superstructures such as columns, beams, slabs and upstands, and includes the installation and grounding of machinery bolts. The project is physically divided into 5 sectors, and they are: the main building that holds the rolling mill itself, the water treatment plant, the high voltage station, non-plant building, external works. Let's begin in the main building with the first section, the billet storage area. This area is where the raw material billets are delivered and stored. The area provides over 3,000 square meters of storage capable of holding up to 60,000 tons of billets. The floor slabs and the floor storage area have been designed to handle loads of up to 30 tons per square meter. This storage area will be served by 3 overhead magnetic cranes. The cranes will be used to feed the billets into the gas-fired furnaces. From this point on, the entire manufacturing process takes place 5 meters above the factory floor. Not only did the furnace design require an elevated production line for maintenance efficiency, an elevated production system is ideal to allow technicians easy access to the equipment without the need for underground tunnels and passages. The walking beam furnace is considered to be the heart of the mill, spread across 1,350 square meters. Here billets are subject to temperatures up to 1,200 degrees Celsius, technically called the rolling temperature. The furnace itself is supported on a very complicated reinforced cement concrete structural foundation, with pedestals and beams to resist the huge dynamic loads created by the walking beam within the furnace. Once the steel billets clear the furnace, they are discharged into the rolling mill area. The rolling mill area consists of 3 stages: roughing, intermediate, and finishing. The built-up area of this section of the mill is approximately 4,500 square meters and consists of reinforced cement concrete platforms at an elevation of 5 meters, reinforced cement concrete supporting walls reaching heights of up to 9 meters, reinforced cement concrete flumes and trenches to direct cooling water towards the water treatment plant. Hydraulic rooms which control all rolling equipment are located below the rolling platform. Once the finishing is complete, the steel bars will make their way towards the thermo-processing area. With a built-up area of 1,300 square meters, the thermo is where the finished bars are cooled at approximately 500 degrees Celsius. This is done by passing the bars through a long thermo-processing cooling table installed on a 5-meter elevated reinforced cement concrete platform. From the thermo-processing area, the bars will make their way towards the cooling bed area. The 2,500 meter square cooling beds are installed on reinforced cement concrete platforms at an elevation of 3.6 meters above the factory floor. Cooling beds naturally cool the material as the bars make their way towards the production discharge, where the rolled bars move to an exit shear area. At 200 square meters, the exit shear area is where bars are cut into standard lengths and transported to stacker and bundling sectors. At the stacker and storage area, the final product will be bundled and stacked, ready to be dispatched to construction sites. This is the final stage of production process and is located on a reinforced cement concrete platform at an elevation of 3.4 meters. 16,000 square meters of storage area is provided for the final bundled product. In this area, the steel bars return to ground level. Similar to the floor slabs in the billet storage area, the floor can handle and hold 30 tons of steel per square meter. The first electric control room is the largest. It is dubbed ECR1. It's a G+1 reinforced cement concrete facility with a built-up area of 3,120 square meters. Water is a major resource for the steel plant to cool the steel bars. Therefore, a water treatment plant is available on the premises to filter, cool and recover water used during the production process. The water treatment plant consists of 7 sections. The scale pit is a reinforced cement concrete water tank measuring 18 meters by 8 meters with a 6-meter height. This is where the water from the flume trenches will be diverted to. The water will arrive at the pit loaded with scale materials created while rolling the billets. These scales will be caught within the scale tank and discharged through a special overhead crane installed at the top of the tank and is supported by a reinforced cement concrete frame. The second section of the decanter tank, which is a reinforced cement concrete water tank measuring 41 meters by 13 meters with an 8-meter height. In this tank, all suspended solids in the water will be separated and discharged through special tunnels in the sludge tank, and the water will be pumped towards the cooling tower. Before reaching the cooling towers, the water will be further cleansed using quartz filters. The filters are located within a 111-ton steel tank supported by reinforced cement concrete foundations. Once filtered, the water arrives at the cooling tower. The reinforced cement concrete multi-level building, 22 by 8 by 16 meter high, is where the water is cooled naturally with giant fans. The cooling towers measure in at 22 meters by 8 meters with a 16-meter diameter. The pump room is a reinforced cement concrete building, 205 square meters in size, where all pumps from the decanter tanks and cooling towers are controlled. The goal of the water treatment plant is to allow for the reuse of water. Nevertheless, some water loss is expected due to evaporations in the cooling process at the main factory. A 120 cubic meter recovery piezometric tank has been installed on a 30-meter high steel tower to supply the factory with any lost water. This has been an overview of a typical steel mill constructed by the Amana Group. For more information, please contact us on the following numbers.